So hello and welcome. My name is Christopher Leonard. I'm the global lead for VirAlert. I'm looking after the commercial and product development side of things, and joining me today is our physics expert, Dr. Fiona Turner. Any questions that you may have as we go through, please put those on the right-hand side. You'll see a click down where you can submit questions, and we'll address any questions you have as we move through this. We've got a couple of questions that have been pre-submitted that we're going to address and talk through initially, and then we'll pick up with any further questions as we move through the presentation. So just before we begin, I'd just like to give an introduction to who Amatek Land is. So Amatek Land have been around since just after the war, since 1947. We've got over 7 decades worth of experience measuring temperature accurately with non-contact temperature instruments. All of the instruments are designed and manufactured in our UK HQ, along with UCAS and world-leading calibration facilities. We've been in this business for a long time. We have extensive expertise, and we've brought a number of innovations, world first, to market. Beyond our usual industrial targets, we also have extensive experience working within human body temperature measurement, stretching back to the original SARS epidemic in 2002. Human body temperature measurement can be quite challenging because of the low levels of energy that are involved. And part of the challenge that we overcame back in 2003 was patenting in-scene calibration, which we'll touch on a little bit more as we move through the presentation, and how important that is as an integral part of accurate and reliable temperature screening. We've also got a track record. There's over 1,000 of these systems installed globally, stretching right back into 2003. So the expertise that we have is very deep. We understand this technology very well. And unlike a number of new entrants into the market, we can absolutely stand behind the claims that we make, and they can be substantiated. As I said, COVID is a major challenge, with economies looking to reopen and remain open without causing surges of infection. The core mitigation methods of social distancing, hand hygiene, and face coverings, when incorporated with temperature screening, can play a vital part to giving that additional resilience and helping businesses to stay open. In this case, food processing, which is a very challenging environment. COVID has been found to be very resistant in refrigerated and lower temperature environments, and therefore the sort of core mitigation methods, when supplemented with temperature screening, can provide that additional resilience to keep facilities open. Just going into some of the mitigation methods, none of them are infallible. Face coverings and masks can be uncomfortable. They can be impractical for people with certain health conditions. Typically a one-size-fits-all, and you wouldn't have to see much news coverage to see many instances of masks worn improperly. And indeed, if the mask is not worn and treated in a clinical manner, it could actually exacerbate and increase the risk of infection of the individual wearing it. So it's not infallible. They do have their place, and with the other measures can increase resilience. Same is true of hand hygiene. Hand hygiene has been proposed as one of the key measures to stop the spread of the virus. But again, this is not infallible. It's only valid until you touch your eyes, nose, mouth, or other source of potential infection. As we said, COVID can be very resilient, remaining infectious between 2 hours to 9 days. In a food processing type environment where you've got refrigeration, it would be towards the longer end of the scale, posing a bigger problem. That means that sanitation can be very onerous, particularly where you've got high traffic. Trying to keep those areas sanitized and clean 24 hours a day can be a very tough task. And then social distancing. The infection rates drop dramatically as you increase social distance. But many activities that is not fully practical and difficult to maintain. And again, in food processing plants where space between operatives can be a challenge based on the process, these measures, whilst they mitigate risk, do not eliminate it. Adding temperature screening into this, if implemented properly with the right equipment, can be an excellent measure to add to these mitigating measures and increase the resilience of the business. But as we're going to explore now with our expert Fiona, if they're not implemented properly, you actually may not be mitigating a risk, and may actually be increasing it. Where is this applicable? Essentially everywhere. The potential for this technology is very wide. It goes across all the markets, from education and public and transport through to manufacturing, food processing, sports and leisure. It's applicable in all of these environments. At this point, I would now like to introduce our physics expert, Dr. Fiona Turner.
Hello, everybody. I'm here to talk about the different options for thermal scanning and sensing of human body temperatures with you. I'm going to answer a few of the questions that have been posted in advance to start with, which is about the different options that are available to you. Okay. I'm head of physics here at Land Instruments. I've been working here for 10 years developing different thermal imagers, handheld pyrometers, fixed installation pyrometers and scanners. Most of our equipment is going into industrial applications, such as the steel and glass industry traditionally, but more recently we have been developing the thermal imaging for body scan measurements.
Thank you, Fiona. One of the questions that we've been asked and that comes up quite regularly, I was wondering if you could share some of your knowledge regarding handheld temperature screening.
Right. Well, as I said, we make handheld pyrometers, but we don't actually make them for the human application because we don't think they're the best idea. The reasons are manifold. Firstly, you've got to have somebody operating it. So while it seems to be a cheap, available piece of kit, you've got to have a person's salary factored into that. And that person introduces quite a lot of variation. It won't be the same person every day. And we find when people are making industrial measurements that you'll notice that one particular night shift, or the glass tank seems to be running cooler. No, it isn't. It's the operator on that night shift likes to point at a particular object through the peephole. So if somebody looks at your forehead and somebody else looks at your nose, you'll get a variation of a couple of degrees. So there's that difference. There's putting somebody also right in the front line, meeting everybody with their new germs as they come into the building, and then meeting all the regular employees and passing them on. So there's that. They can vary in accuracy. As I say, it's not the solution that we would recommend. There's no reference measurements. The distance that you work at can be a factor. It's more the target area.
So just to clarify, so that the audience is clear, what we're talking about here is non-contact thermometers, not a contact clinical thermometer. So a contact clinical thermometer would be the type that were you to go to an ER, they would contact and put within your ear to get an accurate temperature. Obviously, that's a very accurate way if you're using a clinical calibrated thermometer, but obviously you're then very much invading social distance. It's quite invasive to the users. It can be quite a slow process. What we're talking about here is the readily available handheld thermometers or pyrometers on the market. With respect to those, what would your comments be about accuracy, Fiona? I think you've touched on one of the instances that we recognise in terms of variance between operators and variance even between readings from the same operator. But if you were to take out that variance, could you talk a little bit about the overall accuracy of these devices and whether they're suitable for the purpose?
The the ear thermometers are very accurate, as you say.
Yes.
But that's for a rather slower and closer approach thing. The handheld pyrometers that are used from a distance to screen people as they come into your facility in the morning, those are not so accurate. I don't really like to comment on other companies' accuracy, but they cannot be achieving better than 2 or 3 degrees.
Okay.
Because you just can't without a reference source that's in the.
Could you just talk us through that a little bit in terms of the reference source? So I appreciate commenting on a specific manufacturer without looking at the details is not possible, but the fundamentals of the science in terms of that reference source to get that accuracy, because as you say, plus or minus 2 degrees is not really going to give you the right results. It could be giving you false positives or negatives. You could be letting people pass that have an elevated temperature, or inadvertently stopping people that don't.
Absolutely, yes. So accuracy, it sounds like a physics word, doesn't it?
It does.
A real person doesn't care about the accuracy so much, but what they do care is that they get all the healthy people coming into work in the morning and all the unhealthy ones very definitely outside the doors.
Excellent.
Yes, so the accuracy really does matter.
Okay. Thank you. The other question that we've been asked is at the other end of the scale. So handheld non-contact thermometers seem attractive, as you say, cheap purchase price, $40, $50 off Amazon, easy to use apparently, without the sort of the further education of some of the limitations that can seem quite attractive. At the other end of the market, moving on to multi-person or crowd scanning thermal images. So this would be much higher price point, much higher resolution thermal images, which seem quite attractive. Could you just tell us and give us a little bit of background, again, looking at the accuracy and some of the benefits and limitations of multi-person or crowd scanning?
Well, some of these thermal images are great pieces of kit. They've got thousands of pixels, fantastic view. The accuracy, if you're in a lab environment, their accuracy could be great as well. But the problem is the way they're being implemented to measure a crowd. The crowd are all at different distances and you've got different views of them. So some people, if the camera's mounted slightly above you, some people have more and less hair than others. And you're going to see a bigger area of them. You're going to see the hotter and colder parts of their face. The best thermal imager struggles with measurements of the same target at different distances, different apparent sizes. Even the best ones do. So
controlling the variables when you're recording a thermal image and trying to deduce temperatures is absolutely key to this.
It is, yes. The best thermal imager cannot work to sub-degree accuracy at all distances from the thermal imager,
okay.
Without putting a reference in the frame.
Yes.
As I've mentioned before.
So when you say a reference, can you expand a little bit on the what would be a reference? Can you give the audience
an object of a fixed temperature?
Okay.
So that then it's something that is very similar in temperature to me,
yes,
but not quite. And then you'll see the variation, and it kind of it's like highlighting that small temperature range.
Yes, so having the fixed known temperature within a scene, you can then work with minimizing the other variables. So if you know where your subject is, you can have your software to account for that and give you greater accuracy in the real world.
Yes, almost like zooming in on a part of the temperature sensitivity region.
Okay.
If you've got that reference in the image. The other thing, I knew you were going to use this picture.
Yes.
And the other thing is that thermal images, this picture is right.
Yes.
People are selling these because they look fantastic. But why would this gentleman's tie be a different colour to his shirt collar? Neither of those are actually touching his body, so they're going to be the temperature of the room, aren't they?
They are.
These people, their noses appear hot. People's noses are colder than their cheeks and their foreheads because the nose sticks out. Women in particular have colder noses.
Okay.
So there is some fake imagery around with the thermal crack scanning. There's some other products where people don't fake imagery. This is just a stock image. This isn't a lab thermal image, I should say. I know this one being used for the presentation, but it does show the difficulties that you've had to identify these people. But even in this, they've chosen people at about the same distance from the camera. There isn't a little child in the corner over here with a very small face.
Yes.
They are trying to give it the best chance.
So just thinking about that, Fiona, the fundamentals seem to be the same whether you're looking at a handheld or whether you're looking at a sort of a very high resolution and expensive thermal imaging camera. It's about controlling and managing the variables, the unknowns within a certain setup or application where you're using this, and understanding the fundamentals of the technology, what it can and can't do in terms of the accuracy. If you can understand those aspects to it, then you can make an informed choice. Yes,
absolutely, and this is why Land haven't chosen to offer either of those solutions. We do make fantastic high-resolution thermal imaging products for industrial applications, but we haven't gone down this route for the people measurements because you don't need it. You've got far many more pixels than you need. You pay per pixel. Really, yes. In your image. So if you can use a smaller thermal image that's just big enough to image a person, and we do a face detection, not face recognition as well. So you know it's a person and you know you're measuring the face, but you don't actually have any of the privacy issues from that. That's all you need. And if you have thousands of people coming through your gates every day, then you would need more than one of our system. But actually, you might be able to handle the same number of people a lot cheaper with multiple small thermal images than going for the grand fancy looking red, blue, green and yellow image that we have on show here.
Yes, thank you. Just summarising, we're obviously manufacturers of thermal screening solutions. What I think we're about to cover here would be true for all similar systems, although I'm struggling to find a reference that's comparable in the market. But I think just talk to us a little bit about the single person screening and the integration of a black body and the importance of those, if you could, for us, Fiona.
Okay, well, you can see our reference black body source here. This is very, very tightly controlled at very close to the average human body temperature. I think it's controlled at 38 degrees. And then we've got our volunteer who we both recognise this volunteer. The visible image is being used for face detection, not recognition. And then the thermal camera, the thermal image is lined up with it. Now this is a black and white image, but you can see a cold nose there. We've got a live demonstration actually, if you wanted to see with the colour image.
Yes, if I could ask you, so just for our audience members, towards the right of the screen, we have one of the viral alert units set up. So this is our automated temperature screening system. As you can see there, very simple setup. This one's set up with a laptop for portability. It equally can be set up. We have one in our reception with a TV screen. Fiona, if I could just ask you to walk up to the system and demonstrate the ease of use. So here you'll see Fiona's just walking up to the system. Not been quite able to get the camera angles to show that full on. Yeah, if I could just get you to stand to one side, see if the system will still recognise you. So it's a little bit difficult to see. I apologise for that. What we have is facial recognition. So as Fiona's walking into the scene, and if we have time and there are not too many further questions, I'll take you through a little bit of footage which explains that. But as you can see, Fiona's walking up there, the system's measuring and giving a response in less than 2 seconds. So that means that it's automated, you're not invading any social distancing, the cost of ownership is very low because you're not requiring staff to monitor and carry out the measurement. And it also means that the throughput in terms of high footfall applications, the system is ideal for. I'm just going to open up the mics if I can to see if there are any questions from the audience. If there aren't any questions, I'm going to just take the last 5 minutes just to take you through a little bit of footage which may explain the operation of the viral alert system. So, okay, can I ask, are there any questions from the audience? Okay, I'm going to take the opportunity then just to lead you through a little bit of information in terms of the actual operation, so you can see this a little better. Fiona, thank you very much for your expertise and your insights. If we get any further questions as we run to the close, I'll be phoning a friend and asking you to step in again. But thank you very much for that insight. Thank you. So, as we've covered, the Viral Alert 3 integrates all the key ingredients for safe, accurate temperature screening. It's been designed as easy to use and set up in less than 30 minutes. Results in less than 2 seconds and market leading availability. Just click down. This is a piece of footage taken from the Viral Alert system itself. This unit is installed in our reception in Drumfield, just outside Sheffield in the middle of the UK. I will just say for any concerned viewers, this is a simulation, so we do get a red reading indicating an elevated temperature. No animals or staff were harmed in the filming of this. We did simulate that with a hot cup of coffee around the side of the door. So here you'll see James, one of our sales managers, as he's walking up, the system is detecting his face, similar to what functionality you may have on your smartphone. What that does is it ensures that we are measuring a face and not another hot object. Were somebody to walk through here carrying a coffee with another type of temperature screening system, the alarm may well sound because it would be measuring the temperature of the coffee rather than the person. As you can see, there's clear instructions on the screen which can be amended to suit a particular application or installation. And as well as the text prompt, there's also some color coding there. So a green pass, your temperature is not elevated, a grey for the reading process, and yellow while it's taking the measurement. And then we'll see. So as Dave walks up, we've simulated an elevated temperature here. The screen flashed red and detected a high temperature. So it's quick, easy to use. It doesn't violate social distancing. So temperature screening, in addition to hand hygiene, face masks and social distancing, can provide an additional mitigation measure to provide extra resilience to reopen and keep facilities open. It can handle high throughput and all of the liabilities that you may have from a manned system with non-contact temperature thermometers is taken away. As Fiona mentioned, if you've got somebody that is invading people's social distance to take their temperature, you're increasing the risk that those personnel could become infected. And should that happen, then you're massively increasing the risk that everybody entering the facility, their risk of being infected is dramatically increased. And therefore, rather than mitigating a risk, you're actually exacerbating it. So temperature screening can absolutely be a fundamental measure to help us all get past the COVID crisis, but it needs to be implemented with some knowledge, with the right equipment and the right process. And if it's done in that method, it's it's a very valuable tool that can be used. I think we're just about on time. If there's any further questions, we're happy to answer those. Should you have any questions following this presentation, please feel free to get in touch. If there are no further questions at this point, I'd like to thank you all for your time, and we will draw the webinar to a close. Thank you.